Hello everybody, we're moving on to paper 2126 on level 2. If I share my screen, and it's still non-calc, we've got this one and two more non-calcs to do, and then we'll switch into calculator mode. Then you've seen all the non-calc questions that NCFE make available online. Obviously, there are other papers, older papers, that are the old kind of write-on papers, but I feel to get the best experience and give you the best opportunity to get a good score, we're looking at the online ones so you can see what I'm writing, when I'm writing it, and how to get, the most marks, hence at least 10. We've been saying at least 10. If you come out with 15, that is just amazing. So let's have a look. Paper 2126, we're talking a registry office for our topic. As you know, with NCFE, they keep to the same theme. We've got 6 questions to do in 30 minutes. So about 5 minutes a question, but we flip it round and look at the amount of marks it's awarded and think, right, it's just about double that. So we've got about 4 minutes for this one. And this question is looking at, in 2020, there were 0.6156 million births registered in England and Wales. In 2021, there were 625,008 births registered in England and Wales. How many more births were registered in 21 or than 20? So it's a straight subtraction. So we're going to go 625,008. 0.6 of a million means that that's the same under here. 6156. That means 0, 0. And that's the same amount of digits. We've got 6 digits on both. And so we can do the takeaway. 8 take away 0 remains an 8. 0 take away 0 remains 0. 0 take away 6 we can't do, so we borrow 1. 10 take away 6 becomes 4. 4 take away 5 we can't do, so we borrow 1. And that becomes 14. 14 take away 5 is 9. 1 take away 1. 6 take away 6. So we've got an answer there of 9,408. On this one, I'm doing exactly the same. 625,008 minus, I'm going to put my cable around the bottom because I pressed the wrong number then, did I? Yes, I did. Take away 615,600, and there's no other workings out. So I will be literally sticking to that amount of workings out. It doesn't say, can you show your answer in millions? So we can write just the thousands there. So we don't have to look at the point bit here. And we can write 9,408. Would I write births? No, I'm just writing the number in. We could write births, but we'll just write that. Let's go next question. So that was a 2-pointer. This one's a 3-pointer. Look here. We've now got Natalia needs to work out what fraction of the total numbers of births in 2021 were registered in southwest England for a report. Shows this information here. Round both numbers up to the nearest 5,000. So if we go 625,008, nearest 5,000. Okay, it's only 8 over that. So that now becomes 625,000. And that's everywhere. So that's that one. Birth registered in southwest England, so that one is 52239. Nearest 5,000. If you look at this number here, okay, nearest 5,000, we've got that there. Look, it has to go down to 50,000, purely because that number, and it is that number here, is below 50. Oh, well, that's below 500 for me. So if it's 2,501, yeah, we're going up to 55,000 because it's still closer to 50,000 because it's only 2,200. We go down to 50,000. So we've now got our numbers. Use your rounded numbers to estimate what fraction of total numbers of births are registered in England, southwest of England. So we've now got 50,000 as our first numerator, and our denominator is that. Okay, so that's a fraction. Brilliant. We've got 1 mark here for rounding them up. We've got another mark there for creating a fraction. We now need the 3rd mark because it says here, give your answer in its simplest form. Simplest form. Okay, we're looking at these two numbers and thinking, wow, what can we do straight away to get rid of or shrink it? Well, let's divide them both by 1,000 and get rid of the thousands. So we've now got 50 over 625. Okay, so we bring that down to here so we can kind of go. I mean, and rather than think, oh, right, I need to now think of, oh, do both numbers divide by 25, 50, 100? Let's just be quite easy and say, right, do we both divide by 5? Absolutely. 50 divides by 5. That's 10 times. And for this one, off the top of my head, I wouldn't be worried about doing a quick bus stop. 6, 2, 5 with 5. 5's into 6 goes once. 5's into 12, because we've got 1 to carry over, goes twice. And I've got 2 left over. 5's into 25 goes 5. So, okay, I've now cut that one down to 125. And if we look at that number again, I'm going to draw it underneath here again. What do we both divide by? We can see that they both divide by 5 again, because a number that divides by 5 has to end in 0 or 5. So if we divide by 5 again, we can go 10 divided by 5 is 2. And again, if you're not too sure, quick bus stop, takes a few seconds. 5's into 12 goes twice, with 2 left over. 5's into 25 goes 5 times. So we've now got 2 in 25. So we know that 2 can be divided by only 1 and 2. If we divide that by 2, we can't, because it's an odd number. So our final fraction for that, which goes in the box for our third mark, is 2 over 25. But we need to put something else in here to show we've got the right numbers. So we're going to change the 6 to 5 like that. And then we're going to change the 50 into 50 like that. So we can show we've rounded them up. So that's our first mark. Then we're going to put that into a fraction. 50, 1, 2, 3, over 625, 1, 2, 3. And then we're going to go down again. We got rid of the 1,000. So we got 50 over 625. Then we divided them both by 5. And we got 10 over 125. And then we divide it by 5 again. And we got 2 in, well, I lost my little thing, in 25. So we've rounded them up, then we've shown what it's like as a fraction, and then we've shrunk it. And that's your 3 marks. Let's go next. Scroll down a bit. Natalia needs to include the total number of registrations for 2018 in her report. Natalia thinks the total number of registrations for 2018 is less than 1.4 million. Is she correct? Show how you decide. Quite simply, for 2 marks, we're adding these numbers up, and if it's less than, so 14, and then the zeros, that's the bigger number, because it's saying it's less than that, so that's the bigger one. So we want a number less than 1.4 million. And the way we're going to do that is by simply adding these numbers up. To make it a little bit easier on myself to start with, what I'm going to do is I'm going to actually try and set them out into the nice columns that we need to add numbers up. But I'm going to jump down to this second one. I'm going to put them in order first, only because I find it a little bit easier when I've got gaps at the end, not gaps in the middle of my sums. So I've got 200,000 there, 790, and then I've got 1,956. So I've now got all those numbers in nice even columns and really easy to add up. So 5 add 9 is 14, add another one, add another 6, sorry, it's 20 to spare. 6 add 9 is 15, add our spare, that's 22. Okay. Third line, 12, 19, 28, add our spare 2, 30. Okay. 9 add 1 is 10, add our spare is 3, 13. 5 add 4, add our spare is 10. On this one now, 6 add 5 is 11, 12, 13, 14. Okay. So we've now add them all up in columns. You can see if we've got a number here, if we put it in here, 140320. Okay, the crocodile, back to primary school, eats the big number. The crocodile here is actually eating the smaller number. So Natalia is incorrect. Okay, so for starters, we're going to put incorrect because that's our second mark. And then we're just going to say, well, we're just going to write those numbers in. So 95659 add 540509, add 200790, add, well, equals now, add 1956 equals 1403020. Would I do the little bigger than, smaller than crocodile? No, not necessarily. It's only worth 2 marks. I've done my adding. I can see physically that that number is smaller than that number. Therefore, she's incorrect. So I wouldn't worry about putting the bigger or smaller than. I only did it on my workings out here at the start of the question, so we can see we're looking for a number that is smaller than 1400. Okay. Next question, a 4 marker, so a bit more involved. We've done a 2 marker, a 3 marker, and then now a 4 marker. Natalia knows that 4 couples had ceremonies at the registry office last weekend. The table shows the type of ceremony and the age of the person. Natalia makes these 2 statements. So this is quite a common question in the exam where it turns a bit English language. We've got to look at something and write the sentence and say whether she's correct or not and why. Okay, so first of all, she's saying the mean. So when we're saying mean, so we'll stop at that word, mean equals add all up and divide by number of. Okay, then she's saying the age the people who got married were more consistent. The word consistent is only linked to one sort of average range. Okay, and when we're talking about consistency, if the range is small, then the numbers are more consistent, and that supposes common sense. If the numbers are miles apart, then they're not very consistent. So say you've run a marathon, it took you 10 hours, then 3 hours, then 1 hour, then 9 hours. The numbers are all over the place. Whereas if you run a marathon, it took you 4 hours, 4 hours 30 minutes, 4 hours and 10 minutes, 5 hours. Yet your numbers are more consistent. So when we're talking about consistency, we're thinking about range, which is the highest, take away the lowest. That gives us that range. So we've read the question, we've understood what it's asking us, and now we need to prove each statement. So the mean age for all people who had a civil partnership is higher than those that got married. So the mean for the marriage, let's put equals 30. Mean civil partnership equals, we don't know yet, do we? So we'll add all these up, 29, sorry, add 26. Add 27, add 46. 9, 15, 22, 28, 2, 4, 6, 10, 12. So we've got 128 divided by 4. 4 occurrences. 4s into 12 go 3 times. 4s into 8 go twice. So the mean age for civil partnership is higher at 32. The mean age for people at a civil partnership was higher than those that got married. Statement A, okay? Natalia is correct as the mean for, I'm going to write civil partnership is 32 and is higher as marriage. Oh my gosh, marriage is 30. Okay, so we've done 1. Space for working out there, I would simply put 29, add 26, add 27, add 46 equals 128 divided by 4 equals 32. So we've straight away put there, we know what the mean is for the marriages because we've put all the numbers in there, and that's 1 point for working that out. And we put the statement, so that's the second point. So for the third point, we're looking at now consistency, which we said is always linked to the range. So we can scroll down a wee bit. Let's give us No statement here, as in it doesn't give us the range for any of them. So we can put marriage range equals, right? The highest number in the marriage is 38. The lowest number in the marriage is 24. So minus 24 equals 14. The highest, so we put civil partnership range equals, highest number is 46. Lowest number, 26. So the civil partnership has got a higher range of 20. Now we can look at the statement and we can write both in there as well. The age is of people who got married were more consistent. Absolutely, because it's a smaller range, so therefore they're more consistent. If you look at those numbers, quite obviously that 46 makes the range for civil partnership a bit out of sync. So yes, we can see that the range there is higher. So on here, I would put 38, I won't even write marriage or civil partnership in here. I'll put just the numbers 24 equals 14. Underneath there, 46 minus 26 equals 20. So we can clearly see here the workings out we've done. On here, I'm going to put yes, married ages were more consistent. As the range was 14 and the civil partnership range was, oh my God, put Ranger, Mountain Ranger was 20. That's it. Oh, 200 flipping out. That's right. So yes, married ages were more consistent as the range was 14 and the civil partnership range was 20. We've now said yes and how, and we've got 4 marks. You can see English is not my strong point. Writing sentences in a maths exam to me is a little bit foreign, but hey, we'll get used to it. It's numbers, but when we're talking about range and consistency, yeah, always think of it as just the range, but it's highest takeaway, lowest, but they sometimes disguise it as the word range, consistency. They sometimes sneak it in there. Okay. Natalia needs to buy a table, needs a tablecloth, never mind, buy one. She needs a tablecloth. The table in a ceremony room. The tablecloth must reach down to both, all sides on the floor. Calculate the minimum length and the minimum width that she needs. Space of working 3 marks. Of all the non-calc questions or all non-calc papers, I am always thinking that this one in particular is one of the easier ones. And I know not necessarily easy for everybody, but you can see some of the questions aren't really stretching when it comes to fractions, aren't really stretching when it comes to kind of like looking at pi. So yeah, definitely, if you were to get a question base like this, I would be happy to, say, right, we're all going to get strong answers here. Okay, so we've got on this table, it's shaped like that. And from the side, it's shaped like that. Okay, so we've got to go up. We definitely have to go up from the floor. So it's 7.25. So I'm going to put 0.725. Then I'm going along 1.82. So I'm going to go 1.82. I'm going to put a 0 in there because I like all my columns straight. And then I've got to go down to the floor again. Okay, 0.725. Same on here. Up 0.725. I've got to go along, which is now 0.9, and then I've got to go down again 0.725. So I've got to do it the same sum, 0.900, 0.725, and quite simply, that would be my answer. Add them up. 5 add 5 is 10, spare 1, 2, 4, 6, spare 1, 15, 22, spare 2, 2, add 1 is 3, 5, 10, spare 1, 2, 4, spare 1, 16, 23, spare 2, 2. Okay, so I've now worked out my length and my width. So it would be 3.27 by 2.35 meters. But it's already said that on the thing, so I wouldn't necessarily put that. And again, we know our length is 3.27. It doesn't say up to the nearest centimeter, nearest meter. It just says calculate the minimum. That will be the minimum because we've gone up, along, and down, and down. So on here, I'm going to simply say 0.725 add 0.725, add 1.82, and that equals 3.27. And then underneath again, 0.725, add 0.725, add 0.9 equals 2.35. And that's my two markings there. I've got one for that, and one for saying the man's answers in the box. Okay, last question. And it's a one marker. Sometimes you go like 2 marks, 2 marks, 1 mark, 3 marks, 5 marks. So if you're thinking, oh, I've run out of time, and it's a 6-pointer or a 5-pointer left, spend the first 30 seconds of your exam, no more, just having a look how much each mark's worth. Not necessarily what it involves, but just the number of marks. And you think, actually, if I run out of time and I've got 5 points at the end, why don't I do that one first? And I might have a 1-pointer at the end missing, because it's better to lose out on 1 mark because you run out of time than 5 marks you run out of time. So luckily, this one's a 1-pointer. Okay. Natalia needs to cut a ribbon to decorate 12 chairs. The total length of ribbon is 27.3 meters. Calculate 27.3 divided by 12. So she's saying calculate 27.3 divided by 12. Okay. Those of you who know me and have seen a few of these videos, I'm straight away bumping that up by timesing it by 10. Then I can divide it by 10 when I've got my answer. So I'm straight away saying I've got 12. I've now just got 2, 7, 3, because I've upped it by 1 decimal place. So in other words, I've times it by 10. Not both sides, because that's a normal number. If I did both sides by 10, then I wouldn't have to do anything to my answer, because I've done the same to both sides. But because I've only done this side by 10, I need to make sure when I'm doing it backwards, I need to put that in. Because if you look at that, 12 is at 27. It's going to be 2 point something, because 2 times 12 is 24. So when we get here, 20 something, wow, that's a big number. Okay, so 12 into 27, we've got twice, haven't we? Because 2 times 12 is 24. So we've got 12, 24, 36, 48, 60, 72, 84, 96. That should be enough. So 12 into 27 go twice to 24. So that means we've got 3 left over. With that 3 left over, 12 into 33. Okay, we can see that 12 into 33 go again twice. So the difference between 24 and 33 is we've got 6 up until 30 and then another 3. So we've got 9 left over. If we think about that 9 left over, we can see now it doesn't go into 9. So we're going to put a decimal place in there. 12s into 90. We did enough. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9 times. No, 8 times. What am I doing? 1, 2, 3, 4, 5, 6, 7, 8. Well, I'm driving myself bonkers. 8 times. No, 7 times. Oh my gosh. Steve, what are you doing? It's Monday morning and you're getting questions wrong already. That's not good enough. Okay. Well, 12s into 90. 1, 2, 3, 4, 5, 6, 7, because 96 is too big. So we've got 84. So we've got 7 times and we've got 6 left over. 12s into 6 don't go. 12s into 60 go 5 times. Okay, so now you can see, remember when I did it first off, I times my number by 10 to make this one a whole number. I now need to make this number 10 times smaller. So the decimal place moves 1 place to the left and it becomes 2.275, which when we said at the start, if we're thinking 2's into 20, 12's into 24 is 2 and a bit, absolutely works, 2 and a bit. What would I do in my working out box for a 1-pointer? Exactly what we've done there. 3, oh my gosh, 27.3 divided by 12 equals 2.275. And it's a 1-pointer, so when it says space for working, it's just the sum we've done. I wouldn't worry about, oh, I times it by 10, so I've got to divide it by 10. Keep that to your workings out on your pad and do it like that. Okay, and that will be the end of that question paper. Like I keep saying, if you've think, oh, maybe I've made have a quick check at them all. Just I've got a number in the right box or a yes or a no. Yes, it's a number. Yes, it's a fraction. Asking us, is it correct or incorrect? Yes, in my box, I've got the answer, not the number. The two statements, have I written statements and not numbers? Yes, I've written statements that I agree and I agree again. Then I've got my measurements, which wants a number in the box, and then it wanted a number in the box. So all my answers have the right information in the answer box. Are they all right? Then we'll have to find out obviously when we get it marked. But I would be confident on the answers I've written. And if I'm confident and I've still got 5 minutes left, I'm not going to sit around for 5 more minutes. I want my brain to keep working. I'm going to click next, and that's going to take me straight into my calculator paper, and the timer would start again on 1 hour and 30, and I'd get straight into it. I wouldn't sit and think about things for 5 minutes. I might overthink things and convince myself that, oh, maybe that's not right. Oh, could I have done more? Have a check once. Because if you've done your answers first time around and you're happy with them, you're checking them again just to confirm you've written the right information in the box. If there's another question you're stuck on and you flagged it, then yeah, use the extra spare time to go back and check that one answer and try and see if you can get, if it's a 5 mark, can you get 2 or 3 by going halfway on the question, or can you go for it all and think, I wasn't confident on that last little bit, but I've done, you know what, I've done all I can. So if you have any spare time, use it wisely. If you're confident with your answers, just click next, as in go out of it and click onto the next question, because you don't want to outthink yourself and convince yourself that maybe I got it wrong. Maybe it wasn't asking that. Go with your gut, and then hopefully, fingers crossed, it comes out good. So I'm going to click finish test. I'm going to click stick clock, click stop sharing, not stick clock sharing. And then I'm going to stop the recording and I'll post this out to you all. And any questions, let me know. But as I say, there's 2 more non-calcs to go, which we'll do over the next couple of days, and then we'll jump straight into calcs. So those of you coming up to exam time can be confident we've done a variety of questions across calc and non-calc and prepared you. Thank you very much.